Yes, good morning, everyone. And as far as the yesterday's classes have been considered, we have been learned about this graphical solution method, how to solve the problems regarding the graphical solution method. In today's class, we would like to deal with the R method and the simplex methods, R and simplex methods. There is also a subclassification in the case of linear programming technology. So linear programming, here programming plays a major role, and hence, in the case of this R method, we'll be having an programming just like in the form of an instructions as we have given in the case of C language kind of programs. So C language మీరు already first year లో చదువుకున్నారు. Related to that, the R programming also will be existing with some of the commands, and for that particular purpose, for example, if there is any milling kind of situations, milling kind of operations need to be performed in the workshop, or drilling, any one of the operation, if we consider, we'll be having a particular case of steps to be followed for each and every kind of operational process. Considering milling kind, in the case of milling, we'll be giving some of the instructions to the machinery that when it has to be switched on, how much speed it should be maintained, chunk should be activated, work part should be holded, tool should be selected, and in which part of the work part that is fixed on the chunk, the tool should be operated either in positive x-axis or positive y-axis or positive z-axis, simultaneously in the negative axis. So those kind of operations and moving parallel, perpendicular conditions, maintaining these conditions will be specified in the form of a set of instructions to the system, and hence that is considered as an R programming. Here there is a clear-cut definition related to the R programming, that it's an open source tool that is very much popular among the data scientists for essential data science tasks. Performing this linear programming is very much easy, and getting the optimal solution within a few steps upon solving. So in the graphical solution or mathematical relations or simplex problems, in these cases we have to obtain a mathematical relational equation present polynomial equations, and in the case of linear programming we are having some of the steps that RHS terminology should be converted to the LHS side and should be equated to the zero, and the equation should satisfy with the given constraints that the entire equation should be greater than zero or equal to zero. And later on, if this condition not satisfies, we'll be multiplying with the minus 1, and hence the signature sign will be changed, and entire the equation will be satisfying the non-negative characterization as per the linear programming strategy. Later on, depending upon the number of constraints, we'll be adding the sign variables, extension variables, and next the additive variables. And by that, if the constraints has been satisfied, those constraints also should be feasible for solution generation. that will be calling as BFS, basic feasible solution generating type of equations. If at all the condition hasn't satisfied, we'll be moving furtherly the variables changing. These and all the characterizations that you have been seen in the yesterday's class. In the today's class, we'll be moving on with respect to this R programming. Here, similarly as the C programming, in the C programming, people have written some of the programs for generating or identifying the prime numbers among the given numbers, addition of the numbers, multiplication of the numbers, subtraction of the numbers, and directly the value will be represented when you have been compiled that particular program. You'll be verifying the errors before compiling the program. So because if you haven't cleared that errors, the compilation process will not be taking place. Next, later on, after compiling, we'll be getting the answer directly as per the position given or the characterizations given in the problem. Simultaneously, in the case of this R programming, we'd like to have the solutions depending upon the constraints given to the system in the form of a programming by understanding the question. So these questions may be related to an industrial field or medical field or else an educational field or else any a domestical work conditioning or work monitoring systems. So any kind of problems can be identified and corresponding data has to be programmed in the sequence of steps. That is what we are calling this R program to the system, and hence the system will compile the entire overall constraints and will verify whether these are satisfying the linear programming statistics or not. Just we have discussed those linear programming statistics also. That is equating to 0 must be greater than or equal to 0. Non-negativity has to be satisfied. Then later on the extension variable or slag variables will be adding. And next, in the case of maximization of the problem or minimization of the problem, we will be multiplying the entire equation with respect to a large positive number for the case of minimum, and for the case of maximization of the problem will be multiplying with respect to the negative signature of the large positive number, that is minus m. So these are the steps, four different steps existing in the case of linear programming. So when you have been identified the constraints from these questions given in any of the fields, just we have discussed that either domestical, industrial, chemical industrial, biological, medical fields, etc. Whatever it may be the condition it is, when you have been identified and given the question, so these constraints need to be matched with respect to linear programming conditions. Then only we'll be calling as a basic feasible solution generating equations, and hence the solution will be generated, or else those conditions will not be satisfied for generating the basic feasible solution. We'll be writing it in an oral form or else in the documentation. Moving on to the R problem, R method of solution process. Before moving on to the question, I would like to show you the programming in what way it will be existing. So certain part of the coding system, just you'll be seeing in your CNC programming also in your CAD/CAM subject that we will be approaching in the next year. First one, installing of the linear programming package that is acceptable by for solving the linear programming methodology. So you need to accept that the library of linear programming has to be involved. And here library in the sense, entire the steps that are existing in the case of this linear programming will be given as an reference to the program which is need to be solved. ఏదైతే ప్రాబ్లమ్ సాల్వ్ చేయాలనుకుంటున్నామో దానికి రిలేటెడ్గా లీనియర్ ప్రోగ్రామ్కి సంబంధించిన ఓవరాల్ 4 కండిషన్స్ దానికి రిలేటెడ్ డేటా ఆర్ ఇన్ఫర్మేషన్ అనేది మనం ముందుగానే ఇన్పుట్ ఇస్తాం. సో వెన్ ఎనీ ఆఫ్ ద కన్స్టెంట్స్ హ్యాస్ బీన్ గివెన్, అంటే ప్రాబ్లమ్కి రిలేటెడ్ కన్స్టెంట్స్ వచ్చినప్పుడు ఆటోమేటికల్లీ ఇట్ విల్ డిటెక్ట్ ఫ్రమ్ ది లైబ్రరీ. దీన్నే మనం డిఫాల్ట్ వాల్యూస్ అని కూడా అంటాం. డిఫాల్ట్ వాల్యూస్. సో ఆ డిఫాల్ట్ వాల్యూస్లో నుంచి ఇన్ బిట్వీన్ ద డిఫాల్ట్ వాల్యూస్ whether the given constraint equations are existing or not, it will be verified. Simultaneously the program will verify. So within that library existence law unte, then the equation is called basic feasible equation and hence it can generate the solution. అందులో కనుక లేకపోతే hence it cannot generate the exact optimal solution. That is the condition, right? Okay, next one, setting the coefficients and decision variables. So overall the variables, we are having 3 different types of variables as we have discussed earlier. Those variables need to be satisfied with respect to the constraints and major objective constraint, that is as per the program we have to give. And next, mathematical relation, matrix, and defining the constraints, right? Based on the given problem we have to define the constraints, and in such a way the sequence of steps as per as this uh, C language program that we are existing, that is a hash include studio.h, hash include conio.h, math.h, and next get ch. Overall description we will be giving later on. Integer values need to be taken in between these values from 0 to 20 or backslash n. N is equal to, will be giving the particular number, and printf of the values backslash n, and the n variable has been specified again, scanf value, and finally the get ch and solution generation solving. So this is the C programming format, and simultaneously we are having the a similar kind of programming in the case of this machinery understanding language, or minimal commands or codes giving to the mechanical systems to function or to generate based on the given constraints the solution to the given problem. So that we need to grasp by giving a small codes or a tiny codes which are useful to solve the entire problem. So moving on to the problem, this is an example problem. This problem already have been discussed earlier, but I will be repeating again and repeating this again. Those who have not at all gone through that particular class can be aware of it. So a toy manufacturing organization manufactures 2 types of toys, that is A and B. Both the toys are sold at 25 rupees and 20 rupees respectively. So toy A is sold at 25 rupees and toy B is sold at 20 rupees. So type A and type B. Type A toys are 25 rupees for each and every piece, and in the case of type B, each and every toy is sold off at a price of 20 rupees. There are 2000 resource units available every day. So there are 2000 resources. So 2000 resources in the sense Selling it's okay. So for selling, the retailer will sell the entire toys. But for that retailer, 2000 sources are existing for supplying to him. So those many distributors are existing for him to deliver the type A and type B toys for his shop, and then he could able to sell those type of A toys and B toys. In this, which a toy A requires 20 units, while toy B requires 12 units. So indeed to reach his demand, that particular retailer demand, he need only 20 units for type A toys, and for type B only 12 units out of 2000. So out of 2000 he need only 32 units, nothing more than that. So both of these toys requires a production time of 5 minutes. So both these resources require to produce the time of 5 minutes. So the demand that is existing for that particular retailer is a matter of production time for resources 20 plus these 12 32 units, a matter of producing only 5 minutes only for that particular one retailer. So total working hours are 9 hours a day, but entire that production units 32 units will work for about 9 hours a day. What should be the manufacturing quantity for each of the pipes to maximize the profits? So hence, he's asking the question is clear cutly. He's asking that what should be the manufacturing quantity for each case of the toys or pipes, toys. We are considering the toys to maximize the profits. So for maximizing the profit, we are having two different conditions in the case of linear programming, that is minimization and maximization. In the case of maximization, we are having that we need to multiply the large positive number in the negative sign value to the obtained optimal equation. So we'll be generating the optimal equation and have to find the maximum profits that are gained by the particular industries when, if the quantity required for retailer can be manufactured in 5 minutes, but on an overall that 9 hours, if the time has been spent, what will be the maximum profit gained by the manufacturers need to be found. So these are the constraints. We'll be developing the mathematical relations depending upon the equation, and we'll be moving on furtherly. So the objective function in here it is, we need to find out the maximum z considering x as an pipe A and or toy A and y as an toy B. So we have to find out the maximization equation. There is a major equation need to be found out. For that, what are the constraints given to us? Out of 2000 manufacturing units, we require only 20 for X manufacturing and 12 for Y manufacturing. And hence, this is definitely less than or equal to 2000. But linear programming constraint ఏంటంటే మనకి must be greater than or equal to 0. But here, when it is constraint has been in non-negativity. When this 2000 has been taken into the RH is taken into the left hand side, simultaneously it will be equating to 0. That the action need to be performed in the second step. Simultaneously, in the case of this, next we are having another one more constraint, that is in the form of a code generation we'll be looking at. So substituting of the similar values over here, and for both the conditions we are having a time factor we have forgot it. So time factor in the case of minutes. So for both the X and Y manufacturing, in the question it has clearly cutly given that production time is 5 minutes. So here 5 minutes for X, that is 5 p.m., type A twice and type B twice, and less than or equal to, it should be 9 hours of production time entirely we are having. So 60 minutes per an hour, 9 6 are 54. So hence overall 540 minutes, and this is considered as a second constraint. So first one, it is a production unit constraint. Second one is a time factor constraint. Next, installing the packages, library, setting the coefficients of decision variables, and objective is nothing but indeed to find or sell by that particular customer, it is 20 for A type and 20 B type. So constraint matrix. So constraint has been specifying here. So constraint matrix ఏంటంటే matrix of C should be of 20 and 12 depending upon the time factor 5 and 5, and considering it is an row 2. So and again furtherly defining the constraints. ఏమున్నాయండి కాన్స్టెంట్ టైం దట్ ఈస్ 540 minutes to be taken, and resource also 2000 only. Among these resources only you have to identify. But we have already discussed that RHS is and constraints. So you have to define that RHS for constraints. In that RHS constraints లో మనకి ఏమేమి ఉన్నాయండి? ఫస్ట్ వన్ రిసోర్స్ ఒకటి, రెండోది వచ్చేసరికి టైం ఫ్యాక్టర్. సో టూ constraints are existing in the case of this RHS terminology. So that you have to specify here. Next one, direction of the constraints. So constant direction generally etundi for both the constraints, resource kanivandi, time ki kanivandi, less than condition ఎక్కువగా ఉంటుంది. So hence whatever nominal conditions we will be taking that less than or equal to. Next, later on, finding the optimal solution. So optimal solution దానికి డైరెక్షన్ ఏంటి? మ్యాక్సిమైజేషన్ ఆఫ్ కండిషన్. సో మన క్వశ్చన్లో క్లియర్గా అడిగాడు, మ్యాక్సిమైజేషన్ ఆఫ్ ది రిసోర్స్ యూటిలైజేషన్, వాట్ ఈస్ ద maximum profit that you will be gaining upon manufacturing. So that is the question they have been asked. So maximization of objective function. Objective function is the initial step only have been given. By considering this constant mathematics equation matrix generation, and considering this direction generations, and considering this RHS terminology. So by considering these overall constraints in the RHS terminology, we have to obtain the optimum solution by performing the linear programming. And hence this linear programming, for this linear programming, initially itself the library has been specified. From that library, the corresponding values will be, or corresponding feasible a range of steps will be taken from that library in the case of linear programming. And after the solvation, we need to get the summary of the optimal solution that we will be identifying in the series of steps, and objective values of x and y. So among that, అన్నీ మనకు వచ్చేసేస్తాయి వాల్యూస్, ఈక్వేషన్స్, ఏ స్టెప్కి రిలేటెడ్గా ఏ అవుట్పుట్ వస్తుంది అనేది మొత్తం కూడా మనకు రిజల్ట్ వచ్చేస్తుంది. బట్ మనకి అందులో ఐడెంటిఫై అవ్వాల్సింది ఏంటంటే ఆబ్జెక్టివ్స్ ఆఫ్ ఎక్స్ అండ్ వై. సో ఎక్స్ వాల్యూ ఎంత, వై వాల్యూ ఎంత, వై నీడ్ టు ఐడెంటిఫై. అండ్ తర్వాత వచ్చేసరికి మ్యాక్సిమైజేషన్కి రిలేటెడ్గా సొల్యూషన్, అదే ఎంత ప్రాఫిట్ వచ్చింది అనేది హ్యావ్ టు ఐడెంటిఫై. సో ఈ రెండు వాల్యూస్ మనకి మేజర్ అమాంగ్ ది ఓవరాల్ సమ్మరీ. బట్ వాల్యూ ఆఫ్ ది ఆబ్జెక్టివ్ ఫంక్షన్ ఇస్ ఆప్టిమల్ ఆర్ నాట్ అనేది కూడా మనం ఆబ్జెక్ట్ చేయాలి. బట్ దట్ విల్ బి ఐడెంటిఫైయింగ్. సో ఓవరాల్ సమ్మరీ వచ్చేసరికి ఇట్లా వస్తుంది. సో ఫర్ ఈచ్ అండ్ ఎవ్రీ స్టెప్ యూ విల్ బి హ్యావింగ్ ది పర్టికులర్ వాల్యూస్, and going on to the statistical values, that is optimal solution and optimal objective value ఏంటి. సో మ్యాక్సిమైజేషన్ వాల్యూ వచ్చేసరికి దిస్ ఈజ్ ద కండిషన్. అండ్ నెక్స్ట్ వన్, ఆ కండిషన్ రావడానికి మనకి సొల్యూషన్ జనరేట్ చేయాలి. ఆ సొల్యూషన్ జనరేట్ చేసిన వాటిలో ద ఎక్స్ వాల్యూ హియర్ ఇట్ ఈస్ అండ్ ద వై వాల్యూ హియర్ ఇట్ ఈస్. సో therefore in the case of the output, after solvation from the programming structure, we will be obtaining this summary, and among them we have to identify only the toy A and toy B type and maximum profit. So in that, the organization should use 88 units of toy A and 20 units of toy B, and will be obtaining or achieving a maximum profit of 2600 rupees. So among that 9 hours of time schedule, the manufacturing resources utilization only 32 leads to produce 88 units of toy A and 20 units of toys B, and getting the major profit of or maximum profit of 2600 rupees for the organization. So that is the solution generation, and this is the process of identifying is R method. So nothing doing here. We have to specify the constraints, the major objective function from the given equation. You need to specify here. The matrix format need to be specified here. What should be identified, and the constraints need to be defined. That is in the case of time and the case of resource, and RHS terminology as per the linear programming. And for that, you need to satisfy how many constraints are given in the RHS terminology, and directions or direction signs need to be specified, and obtaining of the solution and summary and x and y. If it doesn't require overall the summary, this overall will not be identified here, and you will be getting only the optimal solution value and optimal value. So if you have been summary has been this step has been erased, then you will be getting only the x and y value directly, and solution, that is nothing but the maximum profit you will be identifying. So in the case of this minimal strategy, if there is any minimum kind of problems, then you will be getting the minimum kind of values. All right. So this is the methodology of R method, and we'll be moving on to the another one more problem that is related to the simplex algorithm. Simplex algorithm in the case of linear programming technology. So uh, initially we'll have a glance over these simplex algorithm steps, converting this linear programming to a standard form. So we all know that four different steps of the linear programming should be satisfied, and hence we have to identify that basic feasible solution has been obtained or not, and later on whether this basic solution is obtained or not need to be verified, and determining whether this current basic feasible solution is optimal or not. So if it is optimal, it will be moving on to the calculation part. If it is not optimal, it will be moving on to the initial stage of step for the modifications, right? So here it gives a clarity. So if the current basic feasible solution is not optimal, determining the non-basic variables should be become as a basic variables. So changing of these variables lead to a generation of basic feasible solution. There is a new basic feasible solution, right? And hence later on we will be identifying this objective function and moving to the step 3 again. Nothing but if it is optimal, then optimal solution generation అనేది చేసేస్తాం అన్నమాట. That is the major factor in the case of simplex algorithm. సో మీరు ఇక్కడ ఐడెంటిఫై చేసినట్టయితే almost for big example, big method, big M method of the example, graphical solution method, ఆర్ మెథడ్, సింప్లెక్స్ మెథడ్, మీరు ఏ మెథడ్లో క్యాలిక్యులేట్ చేసినా కానీ లీనియర్ ప్రోగ్రామింగ్లో ఉన్న 4 డిఫరెంట్ స్టెప్స్ మాత్రం కూడా మనం ఐడెంటిఫై చేయాలి. అండ్ ఈచ్ అండ్ ఎవ్రీ ఈక్వేషన్ ఆర్ ఈచ్ అండ్ ఎవ్రీ టైప్ ఆఫ్ ది solving this optimal solution process should satisfy the linear programming conditions. సో లీనియర్ ప్రోగ్రామింగ్ కండిషన్స్ అనేవి చాలా ఇంపార్టెంట్. మీకు 2 మార్క్స్ కింద కూడా అడుగుతూ ఉంటాడు, 6 మంత్స్ కింద అడుగుతూ ఉంటాడు, అండ్ లెటర్ ఆన్ ప్రాబ్లం కనిపించాడు అని అంటే డైరెక్ట్ బిగ్ ప్రాబ్లం వచ్చేసి 14 మార్క్స్ కింద జనరేట్ చేయమని అడుగుతాడు, అంటే 8 మార్క్స్కి బిగ్ ప్రాబ్లం వచ్చేస్తుంది, రైట్? విల్ బి హ్యావింగ్ టు లుక్ ఎట్ 8. Rama Furnitures, it makes or manufactures desks, tables, chairs. Each product needs the limit resources of lumber, carpentry, and finishing. As described in the table, So values has been given in the table that at most 8 tables can be sold per week. So maximum is the weekly revenue. So hence the condition. ఇప్పుడు మనకి ఏమి ఇచ్చాడంటే 3 different products ఉన్నాయి. Lumber, carpentry, finishing. 3 different processes need to be taken place. ఆ 3 different process కన్సిడర్ చేసి ఒక్కొక్కళ్ళు ప్రాసెస్ చేస్తే కొన్ని డెస్క్లు మ్యానుఫ్యాక్చర్ చేస్తారు, టేబుల్స్ మ్యానుఫ్యాక్చర్ చేస్తారు, చైర్స్ మ్యానుఫ్యాక్చర్ చేస్తారు, రైట్? సో బట్ మనకి ఉన్న డిమాండ్ ఏంటి, ఆ డిమాండ్ వెరిఫై చేసుకోవాలి అండ్ వీటి మీద మ్యాక్సిమం రెవెన్యూ ఎంత వస్తుంది చూడాలి. మూవింగ్ ఆన్ టు ద లంబర్, అంటే మనకి ముందు వుడ్ కావాలి కదండి. ఆ వుడ్ అనేది అవైలబిలిటీ ఎంత, డస్క్లు చేయడానికి 8 డస్క్ వస్తాయి, టేబుల్కి 6, చైర్కి అయితే 1. సో మ్యాక్సిమం మనకి రిక్వైర్మెంట్ అయితేనేమో టేబుల్స్ 8, 6 టేబుల్స్, డస్క్ 8, చైర్ 1. సో అమౌంట్ 48 మ్యాక్సిమం అవైలబుల్ బోర్డ్స్లో నుంచి అవి తయారు చేయాలి. సో హెన్స్ దర్ ఇస్ నో ఎనీ ప్రాబ్లమ్ ఫర్ అస్ టు గివ్ ద ఆప్టిమల్ quotients or constraint values. Next, in the case of finishing hours, how many hours of work will be commenced for manufacturing? So 4 hours for the desk, 2 hours for the table, 1.5 hours for the chairs. But we are having 20 hours of time. Similarly, for the carpentry, that is 2 hours, 1.5 hours per table, 0.5 hours per chair. But we are having 8 hours of time. So within that 8 hours need to be manufactured. That is total overall time that is consuming the carpentry to 3.54 hours. So hence 4 hours is ideal. So moving on to the demand category. For the desk, there is no any demand, but depending upon the time basis, they will be sold out. But for the tables, we are having 8 as a demand per week. Each and every week, continuously 8 will be sold. If the environment prefers to conditions, then much more tables will be sold out. So for chairs, it is unlimited, right? So price in that. So for desk purchase it is 60, for table it is 30, and for the chair it is 20, right? We'll be moving on, taking the same linear programming model, x1, x2, x3 వచ్చేసరికి desk tables chairs అని అనుకుంటున్నాం. So we are having 60, 30 and 20 from the prices category for each and every strategy, and majorly maximization of z or maximum profit కావాలి అని అంటే price related to with respect to x1, x2, x3 తీసుకోవాలి. So first equation. Second equation, tabular column ఈక్వేషన్స్ కింద జనరేట్ చేస్తున్నాను. 8 desks, 6 tables, 1 chair, maximum available time, it is constraint. So hence 8x1, 6x2, x3, 48. Simultaneously, in the case of working hours, finishing hours. So here 4x1, 2x2, 1.5, x3, 20. Simultaneously, demand oriented for carpentry hours. 2x1 plus 1.5x2 plus 0.5x3 less than or equal to 8. So that is the condition here. So maximum demand ఏంటంటే x2 tables అనేది x2 కింద తీసుకున్నాం. x2 here tables, right? Tables కి demand ఉంది 8. So x1, x2, x3 is definitely greater than 0. So ఆ కండిషన్ మనకు satisfy చేయాలి as per the linear programming strategy. So solution obtaining here. So how the solution will be obtained? Will be verified. So considering first equation towards the row 0, row 1, row 2, row 3, row 4. So 4 rows కింద తీసుకుంటున్నాం అండ్ సిమిలర్ ఈక్వేషన్స్ ఇక్కడ ఐడెంటిఫై చేసాం అండ్ స్లాగ్ వేరియబుల్స్ యాడ్ చేసుకున్నాం. సెకండ్ స్టెప్ ఆఫ్ ద లీనియర్ ప్రోగ్రామింగ్, స్టాగ్ వేరియబుల్స్ నీడ్ టు బి added. So S1, S2, S3 and S4 taken for each and every equations. And how we'll be analyzing this as a basic feasible solution. So starting stage లో మనం చూడాల్సింది ఏంటంటే basic variables ఉన్నాయా, నాన్ బేసిక్ వేరియబుల్స్ ఉన్నాయా. సో whether almost all the given conditions are is equal to 0 or even greater than 0, and conditions కూడా ఈక్వల్ రైట్ సైడ్ కనుక ఎక్కువగా ఉంటే హెన్స్ ది లెస్ దాన్ అనే సింబల్ క్లియర్ కట్గా మనకి స్పెసిఫై చేశారు. హియర్ ఇట్ ఈస్ లెస్ దాన్ అనే సింబల్ because there is not given any constraints. Here less than or equal to 20, clearly it has been given. So greater than అనేది ఇవ్వలేదు. Hence linear programming condition satisfy అవుతుంది. Hence we can do the determination of BFS solution is optimal. right? So here, next moving on to the second strategy, taking that examining of overall row 1, row 2, row 3 and row 4 need to be taken place. That variables is satisfying with respect to the linear programming conditions or not, right? That we will be consuming overall here upon examining and rewriting the equations as a follows. So similarly, upon generation, we'll be having the values as this, right? Similar equations. All right. So in this, we'll be taking a maximization of a value. So slack variable ekkadayithe large constraint untho, that large constraint is being achieved for each and every case of equation. In that, the maximum value upon solvation will be identifying, that is z value will be considered in the maximization of value, that is z is equal to 240. So obtained basic feasible solution equations are this. In this, x2, x3 and slack variable 3 is simultaneously equated to 0, and obtaining the equations that x1 comprising when x2 is taken into the 0 here, x3 is taken to 0 here, here 0, x1 is simultaneously equal to 4. So consolidation x1 is equal to 4. So S1 strategy. So S1 over here, S3 0, X3 0 simultaneously S1. S1 value will be getting 16. So that here X1 is equal to 16. Simultaneously the S2 value over here, X3, X2 is 0, S3 is 0. Simultaneously S2 will be definitely equal to the 4. So that is the 4. And S4, 8. And finally we will be, upon substituting those values, we will be getting Z value is equal to 240. So that is the optimal solution. That is 240, right? So in that, it is a very much, we will be considering this as an basic feasible solution, right? We'll be moving on with respect to the next, in the next class with respect to the another techniques in the case of linear programming. Thank you.